Chairman of Dissertation Council, and Associate Professor Shahmov Jambulat Norbekovich from Department of Civil Engineering of Eurasian University, Associate Professor Tulebekova Vasil Serikovna, Scientific Secretary of Dissertation Council, temporary members of Dissertation Council, 4 members, Kudryavtsev Sergei Anatolievich, Doctor of Technical Science, Professor, Head of Department of Bridges, Tunnels and Underground Structures, Far Eastern State University of Railway Transportation, Khabarovsk, Russian Federation, Kotov Pavel Igorovich, candidate of Geology of Mineralogy, Senior Researcher of Department of Geology, Lomonosov, Moscow State University, Moscow, Russian Federation. And Orazova Dinara Kazbekovna, PhD, Associate Professor of Department of Industrial, Civil and Transport Constructions, Togoyagurov, Pavlodar State University, Pavlodar City, Republic of Kazakhstan. And Dr. Kaldanova Baljanov Uralovna, Senior Lecturer of Department of Civil Engineering, Karaganda Industrial University, Karaganda, Republic of Kazakhstan. Official reviews presented Adibolam Buminat Khan, Professor of Department of Civil Engineering, Indian Institute of Technology, Madras, Chennai, India. Pranodin Yakov Alexandrovich, Doctor of Technical Science, Professor of Department of Construction Production, Tyumen Industrial University, Tyumen, Russian Federation. And President of PhD Students Scientific Advisors, Utepov Yelbek Bakhitovich, Doctor, PhD, Associate Professor, Active Professor of Department of Civil Engineering of Eurasian National University, Nur-Sultan, Kazakhstan. Professor Zbigniew Lechovich, Doctor of Technical Science, Professor of Geotechnical Engineering Department, Warsaw University of Life Science, Warsaw, Poland. So let's begin registration in the system Smart KZ. The word is given the scientific secretary. Please, Dr. Tulebekova, Associate.
So now I ask dissertation council members and reviewers to register in the information system Smart YNU. Everyone has instruction on how to work in the system. It is necessary to select PhD candidate Mkilima Timoth from the list and click Conducting Defense button, and after that registration button. So now I start registration. Please select PhD candidate Mkilima Timoth. After that, Conducting Defense button and Register button. Use your login and password.
So I click registration button and
Yes.
finish, yes?
Yes, finish.
Okay.
So Professor Jusupekov, Professor Shahmov, completed, yes. Already, yes. And only
Yes.
2 another council members completed the registration. So please continue.
Можно по-русски спросить, если что-то непонятно с регистрацией.
Динара Казбековна, вы регистрировались? У вас микрофон отключен.
Динара, включите звук включите, Динара.
Да. Надо зайти в Smart YNU и надо зарегистрироваться, да?
Нет, все верно. Smart YNU, логин, пароль ваш. Затем выбираем по левой части диссертационные советы.
Карточка докторанта. Зашла.
Да, Mkilima Timoth. Вверху в правом углу видим зеленый кружочек проведения защиты, нажимаем на него.
Сейчас, подождите. Все. И
увидим
зарегистрироваться.
зарегистрироваться, потом финиш, да?
Закрыть.
Закрыть. Ага, все, я вижу, вы зарегистрированы. Следующий, Баужан Кауданова, как у вас?
Все, я
Звука
регистрацию.
нет.
Прошла я регистрацию.
Спасибо. Ага, Яков Александрович. Ой, у вас микрофон отключен, мы вас не
Яков
слышим.
Александрович, звук включите, звук.
Да, сейчас, секундочку, регистрируемся.
Все, спасибо большое.
Один момент.
Ждем.
Почему-то одного постоянного члена еще не зарегистрирован.
Один это
Видел?
я. Это я завершу после всех. Работу
Все, понял, хорошо.
Так, Кудрявцев зарегистрировался?
Так, хорошо. Спасибо.
Так, здесь получается сначала почту вводить, да? Все правильно?
Нет, я вам выслала, Яков Александрович, помните, логин и пароль на вашу почту. Так.
Сейчас, секундочку, да, я в прошлый раз, видимо. Сейчас, секунду.
Могу продублировать. Сейчас, минуточку, я зайду. Почту.
Да, вижу, да.
Значит, там есть ваш логин и пароль, да?
Да.
Угу. По нему заходим.
Угу. Так, статус не выбирается.
Какой статус? Вы через логин, пароль зашли?
Да.
Что вы видите на экране?
Вакциналау. Или на...
Давайте сейчас на почту я вам продублирую именно ссылку, когда вы зайдете именно на этот сайт, где вы должны уже логин и пароль вводить. Вы логин и пароль смогли ввести?
Да. Так, мои данные, мои данные не вводятся.
Нет, смотрите, вы видите по левой части диссертационные советы?
Так, да.
Вот теперь
Вниз
выбираем.
заходим, да?
Да, диссертационные советы, потом докторанты.
Докторанты.
Да.
Угу.
Уходят два докторанта, мы нажимаем на Тимоти Мклима.
Так,
Он загорается голубым цветом, просто вот так голубеньким горит.
Да, голубеньким, все верно.
Да. Вверху в правом углу мы видим зелененьким цветом кнопочку проведения защиты, на нее нажимаем.
Отлично.
Ага.
Так,
Видим внизу
вижу.
регистрация.
Зарегистрироваться, да?
Все верно, нажимаем.
Все, нажал.
Все. Завершить там есть такое? Завершить регистрацию или что-то такое? Почему такое?
Закрыть только есть.
Да, давайте закроем.
Так, и возвращаемся обратно. Собрание.
Да, пока оставьте так. Я пока не вижу, что вы зарегистрировались. Сейчас я обновлю. Угу. Так. Сейчас система пока загружается еще. Давайте, Яков Александрович, в принципе, все хорошо, все проведено, да? Павел Игоревич, как у вас?
Я зарегистрировался.
Все, спасибо. Так, профессор Бумитхан?
Yeah, I have done, but finally I have to close it. Yes.
Ага, close. Click button registration and after that close the window. Так, официальные рецензенты. А вот я вижу, что профессор Бумитхан не зарегистрировался.
Okay, I have to, that conducting defense, I have to first check in.
Yes, please click button, registration.
Is it? I went that.
Conducting
I'll click it.
defense, the first conducting defense, and after that
Yes.
register button.
Where is registration button? Check in?
Check in.
Check in only?
Share with us your window, please. You complete the registration? Yes, you complete. Thank you, professor. Thank you.
Вот.
Скажи, Парович, у вас, сейчас я тоже обновлю, что-то вас пока не показывает.
Асель, am I check-in?
Да, все хорошо. Теперь сейчас я завершаю регистрацию. Всем спасибо. Я тоже сейчас зарегистрируюсь, и все будет нормально.
Good Stalin system, да, unfortunately.
Так, все, мы можем продолжить дальше.
Все, спасибо. Thank you very much. So, thank you, Dr. Asel, for great job. It is for us first challenges for group dissertation registration by smart technology of Eurasian National University. I suggest opening of meeting of dissertation council. The decision is made by open voting. Will be there any other suggestions? No. So who for, please vote for like this. Okay, thank you. So 4-7 person against no, abstains no. It is agreed. Let's meeting of dissertation council consider it open. We proceed to the work of dissertation council on the agenda. The defense of dissertation work of Mkilima Timoth, PhD students of specialty of civil engineering on the topic aspects of embankment dam stability, considering the impact of land use changes in climatic conditions in catchments, аспекты устойчивости насыпных плотин, учитывающих влияние изменений землепользования и климатических условиях на водосборных бассейнах. For the degree Doctor Philosophy in the specialty civil engineering. So I think each member of dissertation council is presented in advance with abstract of the dissertation in the 3 languages. Already you have some like referat, like thesis. So the thesis is Beijing defended the first time. So to announcing the main contents of the document submitted by the applicant and the completes the established requirements, the word is given to the scientific secretary, Dr. Tulibekova Asel Selikovna. Please.
Okay, thank you, Professor Spekov. All documents according to the list of documents to be submitted by the applicant on the dissertation council. In this case of Mkilima Timoth are in place in the meet of established requirements. Reviews by scientific advisors and reviews by official reviewers are received. The draft conclusion of the dissertation council is issued to all members of the council. Okay, thank you. Please, Professor Spekov.
Микрофон отключен.
Микрофон отключен, мы вас не слышим.
Do the members of dissertation council have any questions for scientific secretary of dissertation council? No questions. So in the case, no questions, and we're giving for a report for PhD students Mkilima Timothy. So Mkilima Timothy, how long your PhD report presentation? How long? 20 minutes okay for you?
Timothy,
So please,
please
Professor,
turn on the
please,
microphone.
please, 20 minutes okay for you?
30 minutes, 30 minutes.
The duration of your presentation about 20 minutes okay for you?
He wants 30 minutes. I think.
He wants 30 minutes.
Oh. Okay. Okay, please, Timothy, try to shortly. Try to shortly. Maximum 30 minutes, including your conclusions, please.
So I hope everyone can see the presentation.
Yes, yes.
Okay. Okay, good morning, everyone. My name is Timoth Mkilima, and today I'm excited to present to you key results from the study titled Aspect of Embankment Dam Stability, considering the effect of land use change and climatic conditions in catchments. And just to start with, here we have the main list of contents from the introductory remarks to the conclusive remarks. And to start with the introductory remarks, I will start with the research question. But before I proceed, I would like to highlight something that in general, this study was designed after observing what is currently happening in the Msimbazi catchment in Dar es Salaam, Tanzania. Dar es Salaam is actually the largest city in the country. The fact that this catchment crosses at the center of the city, it has been subjected to significant change in terms of land use cover. And as a result of that, the catchment that was flowing throughout the year has now changed into a highly intermittent one. During the rain season, it comes with huge volume, with very high demolishing power. And after that, the catchment remains almost dry the rest of the year. And also something to note that in 2011, December 2011, the catchment also received the so-called 100-year event that left almost 50,000 people in the city homeless and killed hundreds of people. But every rainy season, the catchment also kills at least a number of people and leaving also thousands homeless. And because of that, the World Bank has invested a lot of money as we speak, just in search for solution. However, to my opinion, I think if not, unless these two factors are well understood, we are still very far from reaching the appropriate solution. Why? Because when land surface cover is changing and climatic events are also changing, no doubt that the general hydrological pattern of any catchment will change. And when the hydrological pattern changes, then likely you will have changes in flow. And when you have changes in flow, then the question we have to ask ourselves as engineers, what happens to the slope stability? And something also interesting to note here that just recently the National Geographic from the United States have included these two factors as among the hidden causes of dam failures that are likely to compromise the safety of dams in the future. So this is the general perspective of the research question. And now let's move to some key aspects in terms of the problem statement. So this is Kinyele subcatchment within the Msimbazi catchment in Dar es Salaam, Tanzania. This is how the catchment was in 2004. But by 2017, this is how the catchment was. But when you have something like this is what happens. You have more impervious surface cover. And when you have more impervious surface cover, then you limit the infiltration to the ground. When you limit the infiltration to the ground, then you have surface runoff like this one. And eventually you have a dam failure somewhere. And also to proceed with the problem statement, here we have a very nice illustration of what is pervious and impervious surface cover. When you have more of a natural surface, then you have less of surface runoff and more of a subsurface flow. And when you have more of a subsurface flow, then it takes very long time for this water to reach a nearby dam. And this gives more time for the dam to accommodate the flow. But when you change the surface into impervious one, then you have more of a surface runoff and goes faster to a nearby dam. And this does not give a dam, the dam nearby to accommodate the flow. So now, because of time, let's also move to research design. In general, the research was designed based on 4 main tasks. Number one is GIS applicability. And from this part, it gives us a go-ahead to proceed with the land use land cover analysis. The results from the land use land cover analysis are used in the stormwater modeling. And the results from the stormwater modeling are giving us the decision whether we include both high water level or reduced water level for slope stability analysis. The methods in general are used GIS, SCS curve number method, finite elements. From the data sets, I use digital elevation models, Landsat satellite images, soil data, and here is the hydrologic soil group, precipitation, observed flow data, and soil data as a geotechnical parameter. And also a total of 5 cases studied, 2 in Tanzania and 3 in Kazakhstan, with 3 virtual models. So let's move to the potential applicability of GIS and land use land cover analysis. From the potential applicability of GIS, here I use the Msimbazi catchment, and the reason for this is that in the analysis I used the so-called supervised method in ArcGIS. And in this approach, it's very important that you develop a base model from a well-known catchment. And from this well-delineated catchment, we can see that the Msimbazi catchment is covered of more impervious surface cover downstream along the Indian Ocean, and keeps on decreasing as you move upstream, somewhere around the Kisarawe Hills where the river originates. And from this part, now, because of course from this phenomena, we understand that the model gave us realistic results from the ground. And I would like also to highlight that it is significantly important before you design a dam to understand whether you locate this dam somewhere here where the land is less developed, or you locate it somewhere here where the land is more highly developed with more mixture of medium intensity and high intensity development, or you locate it somewhere here where you have medium intensity development. And with this, you can be able to project future trends and also anticipate some potential issues that are likely to be linked to the changes in land surface cover. So to proceed with the land use change analysis from the base model, now I was able to proceed with the land use change analysis for the Ndembele catchment. Here we can see from this nice figure how the situation was in 1990 from the 1990 data sets. The catchment was covered more by the wetlands, but by 2011, the catchment is moving more into the medium intensity impervious cover. And for the same Ndembele catchment now from the graphical perspective, now we can even visualize better that from the 1990 data sets, we had more of wetlands, but the catchment is moving towards more of a medium intensity, and we no longer have dense forests by 2011. So going further to the Siddelia catchment in Kazakhstan, we can understand that by 2000, the catchment was more of a mix between the low intensity and the high intensity. But by 2011, the catchment is moving more into high intensity development. From the graphical view, we can visualize better that by 2000, the catchment was covered with more of a low intensity. But right now, the catchment is moving more into medium intensity and high intensity development. So the results from the land use undercover were then used in the stormwater modeling, especially the cave number. And now we, based on the results I obtained from the land use undercover analysis, I was able to model the stormwater in the catchments. So beginning with the Ndebela catchment in Tanzania. So this is the measured flow, the current observed flow. But from the 1990 data set, where the curve number is almost approximately 34.15, the flow modeled was minus 36%. But from the 1995, the flow is minus 32. 2004, the flow is minus 20. But now the most important thing is here. When I modeled the flow with curve number 98, I got approximately 0.3, which is 77% more than observed flow. And when I modeled using the extreme event, I got approximately 1,600% more than the observed flow. But now, when you combine curve number 98 and the extreme event, you get something approximately 3,000% more than the observed flow. You can understand how problematic these two factors are when it comes to catchments and dams. And now going to the Siddelia catchment in Kazakhstan. This is the measured flow. And from the modeled flow based on the current data sets, the cave number was 56.28. And this was the flow in meter cubic per second. But when I modeled the flow using the curve number 98, the flow is 73% more than the observed one. Modeling with extreme events, the flow is 52% more than the modeled one. But when I combine the two parameters, the flow is 157% more than the observed one. But something important also to note here is that for the Siddelia catchment, the land surface curve had more impact than the extreme event in comparison to the Ndebela catchment, where the extreme event had more influence in the flow than the curve number, than the land surface curve. And this is realistic because Tanzania is located within the tropical region. And of course, precipitation is significant in comparison to Kazakhstan as a region. So now, after looking at the flow, now let's move to the slope stability analysis. In general, the design of slope stability analysis based on three main factors, as we can understand that when the flow changes in the catchment, then definitely we have change in terms of water level in the reservoir that affects both steady state and transient conditions. And also when we change the water level or the flow in the catchment, then definitely we subject the embankment into rapid drawdown, either planned or unplanned one. And then we end up with some sort of instability issues. But of course, the stability issues are also somehow related to material characteristics that affect the pore pressure dissipation. So let's start with the virtual models that I investigated, and it was important to start with the homogeneous ones so that I can also understand what to expect when it comes to some real case studies. So from the water level here, we understand that when I subjected the 13 high meter embankment to 6 meter water level, the minimum factor of safety was somehow sufficient above 1 with this kind of steady state factor of safety value. But as you increase the water level in the reservoir and subject it to the rapid drawdown, the factor of safety decreases and we have the so-called total failure. But something important to note here, as I observed in the study, and I think this is where we always do mistakes as engineers, if you focus on the steady state condition, you will find that the factor of safety is increasing with the water level. But indeed, if the same embankment, if is subjected to rapid drawdown, then we have a total failure. So it's significantly important to take into account both the rapid drawdown and the steady state conditions. Similarly, when subjected to 5 days, the same situation. When you increase the water level, the factor of safety values are decreasing, while on the steady state factor of safety values are increasing. And also, I looked into the internal angle of friction as one of the critical parameters when it comes to shear strength. And in general, we can see that the factor of safety values are increasing with the increase in the internal angle of friction. And this is because of the poor pressure dissipation. It is easier when you to dissipate the poor pressure when you have a higher internal angle of friction in the embankment. So from the virtual models, let's quickly move to the case studies. And let's start with the October Dam in Kazakhstan. So from here, from the general perspective, I subjected this embankment into different drawdown rates. And we can understand that, of course, the steady state is constant, but the minimum factor of safety is increasing with the decrease in the drawdown rate, but is decreasing with the increase in the drawdown rate. And here we can see the same, like from the instantaneous, the minimum factor of safety is below 1, while from the 1 meter per day, the factor of safety is above 1.4. And this is the embankment with different Fret grinds from the seepage analysis. And also, as I proceed with the October Dam in Kazakhstan, here we have the reduced level. So I had to reduce the water level in the embankment a bit. And now we understand that if you reduce the embankment, the water level in the embankment, and subject to a rapid drawdown, you have a bit higher factor of safety values, minimum factor of safety values. But something important to note here is that if you compare the factor of safety values from the increased, if you have the normal operating reservoir level, and you compare it with the factor of safety value, the steady state factor of safety value from the reduced, you will find that the factor of safety values from the reduced one reduce a bit in comparison to the when you increase the water level. And also, I increased the water level in the embankment a bit, and here we can understand that if you increase the water level and subject it to steady state, you have higher factor of safety value because of the balancing. The water in the reservoir acts as balancing power, but if you subject to rapid drawdown, then you have a problem. So if you drain the reservoir from a lower level, you have higher factor of safety values. But if you drain the reservoir from a higher level, then you have problems. As you can see that from the instantaneous, we have a total failure. And moving to the Ndembela Dam in Tanzania, I subjected it to I subjected the upstream zone to different hydraulic conductivity values. And we can understand that as you reduce permeability in the upstream zone, the minimum factor of safety values from the rapid drawdown are decreasing, but also if you look at the steady state factor of safety value are increasing. So if you design based on long-term steady state conditions, then you would go for this one. But indeed, this means failure if you subject the same embankment to the rapid drawdown. So in general, I observed that the steady state factor of safety values are somehow inversely proportional to the rapid drawdown factor of safety values. So it's always very important when designing to take both into account and come up with an optimum value that will put the embankment safe for both scenarios. Also, I subjected the dam to reduce level. We can see that the instant drawdown to 10 meter to 10 days, all of them are under total failure, at least for the 1 meter per day. And also from the embankment height, after increasing a bit, we have a total failure for all the investigated drawdown rates. Moving to the Chaldala Dam in Kazakhstan, from the normal operating reservoir level, we see that anything below 5 days, we have a total failure. But if you reduce the water level in the embankment and subject to the rapid drawdown, you have a bit higher factor of safety values. But if you increase the water level in the reservoir, then you have total failure for anything less than 10 days. So at least for 1 meter per day. And also this is just a graphical presentation of the results from the Chaldala Dam in Kazakhstan. And this is from 1 meter per day drawdown rate. We can see that from the normal operating reservoir level, we have something, a minimum value above 2.2. But if you increase the water level in the reservoir, you have something below 2.2. But of course, if you reduce the reservoir level, you have something above 2.5. And moving to the Chaldala Dam in Kazakhstan, similar phenomena was observed that as you increase the drawdown rate, the factor of safety values are also decreasing. As we can also see from 1 meter per day, the factor of safety values are somehow above 2.1, but from the instantaneous ones, the minimum factor of safety value is below 1.6. So it was also significantly important in the study to justify the results based on some methodologies, especially statistical methods. And in my case, I used a very useful tool, the so-called ANOVA, analysis for variancy, to justify the significance level of the differences in terms of the factor of safety values. So from the analysis of variance, if we start with the October Dam in Kazakhstan, the combination of water levels and the instantaneous drawdown gave me a p-value of less than 0.05. This is an indication that the differences were statistically significant, and the factors investigated should not be ignored when it comes to designing dams. Similarly, we can see from the 5 days, we have something less than 0.05. From the 10 days, we have something less than 0.05. And from 1 meter per day, we have something less than 0.05. And this is showing that the differences were statistically significant. And if we move to the Ndembela Dam, different hydraulic conductivities were subjected also to the ANOVA. And the combination of these hydraulic conductivities and instantaneous drawdown, we have something, the p-value less than 0.05. This is also an indication that the differences were statistically significant, and these factors should not be ignored when it comes to the design of dam, similarly to the other drawdown rates. And also for Ndembela, here, remember here it was hydraulic conductivity values, and here it's for water levels. When I subjected to different water levels and under instantaneous drawdown, I had something also less than 0.05, making it statistically significant, rejecting the null hypothesis, and also similar to other drawdown rate, 5 days, 10 days, and 1 meter per day. So moving to the Chaldala Dam, also is subjected to different water levels, and also we can see that the p-value for instantaneous is less than 0.05, making it the differences statistically significant for 5 days, for 10 days also. But when I subjected to 1 meter per day drawdown rate, the p-value was above 0.0, was above 0.05, making the differences not statistically significant. Here there are two things we can note, that at least when we reduce the drawdown rate, we also reduce the impact of water level in terms of slope stability. However, this should be taken with care, because still this one is, the p-value is below 1. which means there are still some sort of differences in terms of the factor of safety values, and should also be taken into account during the design. And moving to the conclusive remarks, from the GIS application, I was able to, using the supervised method, I was able to sufficiently delineate the dam site. And this part should also very well be incorporated during the design. And also from the land surface cover analysis, as we observed from the Ndembela Dam, the medium intensity moved from 1990, from 13% cover to 54%. From the Chaldal Dam, the high intensity development moved from 97, more than 97 kilometers squares, from 9,000 to almost 21. So we can see from 9,000 high intensity development in 2000 to 21,000 kilometers squares of the high intensity development. Therefore, as a recommendation, of course, we have observed that the impervious surface is increasing, but as a recommendation, it is significantly important to incorporate these changes during the design of embankment dams. Also from the stormwater modeling, the combination from the Ndembela, the combination of extreme climatic event and curve number 98 led to an increase of more than approximately 3,000% increase if you compare it with the observed flow. And also from the Chaldara, the combination of the two led to a flow increase of around 830% as a flow increase. Therefore, the extreme climatic event and curve number 98 should always be incorporated in the design. Moving to the slope stability analysis, an embankment of 13 meter high, just changing it from 10 meter to 6 meter, this led to a decrease in terms of steady state factor of safety values for 13.44%. And also to drain plus the rapid drawdown significantly affected the factor of safety values. Also from the Samarkand Dam, the instantaneous drawdown rate led to a factor of safety value that was 32% less than the one obtained from the long-term steady state. And also from the Ndembela Dam, from the hydraulic conductivity values, 10⁻⁻7 led to a factor of safety value less than 0.9, which is 33.5% less than the one obtained from 5.5 times 10⁻⁻5. Also from the October Dam, the instantaneous drawdown rate led to something 48.6% less than the one obtained from 1 meter per day. Also from the Chaldara Dam, 1 meter per day drawdown rate was 37.9% less than the one obtained from the long-term steady state. Now, what I observed in this study is that when you reduce the water level in the reservoir, this becomes extremely dangerous for long-term steady state condition. But when you increase, this becomes extremely dangerous for rapid drawdown. Therefore, when you design a dam, you did something optimum, optimizing, taking both into account and come up with something optimum, so that you can take both like this and this one into account during the design. And here I also had to highlight it in red that from my study, I also observed that when you subject your embankment into rapid drawdown, then 1 day before you finish the drawdown, this becomes the most dangerous day in most of the cases. Therefore, when you drain your reservoir, you have to carefully pay attention on the last day, 1 day before you finish your planned drawdown. Of course, if you are able to plan, but because sometimes the rapid drawdown can be unplanned and be natural. And also, based on the results, I was able to propose a workflow for design of for the embankment dam analysis. And the workflow is like this. If you combine digital elevation models, Landsat images, and soil data, you merge all this data, you come up with soil land use soil map, and you combine with precipitation data, you come up with curve number, you generate runoff, you design your dam, and then you subject your dam into stability analysis. In this way, the design team can take also these two factors into account. And recommendations for some future works. Normally, when it comes to dam, we have this International Commission for Large Dams. It is very unfortunate that this commission does not include land surface cover as one of the significant issues to be observed. It's very unfortunate. And also in 2020, I was able to get a chance to review all the documents that were used in the design of Ndembele Dam in Tanzania. It was also very unfortunate that none of the document speaks about land surface cover change. And also, you may also notice that in my study, I focused on the upstream zone, but I think in the future, the other studies could also focus on the downstream phase of the embankment. And also the combination of earthquake, taking all of these parameters into together, like earthquake, rapid drawdown, climatic events, and land surface cover, and then investigate. And also something important that if it's possible to develop a single comprehensive tool that would just take all these factors into account for the stability analysis of dams. And here we can look at the publications, 5 articles in the journals recommended by the Ministry of Education in Kazakhstan, and 3 articles in international conferences, and also 3 articles in the international journals, in peer-reviewed journals. And that's the end of my presentation. Thank you very much. If there are any questions.
Thank you very much, Timothy, for your informative presentations. So please, questions, if you have, from members of Council dissertation. Questions can make oral or by write. So please. So please, Dr. Kotov.
Okay, thank you for presentation, and I have 2 questions. First, there are different type of slope stability calculation. Could you tell about your model, more detail, and especially what kind of soil characteristic did you use in calculation? This is the first question.
Mm-hmm. You said there are 2 types of slope stability analysis?
Yes, there are different type of slope stability calculations. What kind of model did you use in your work, and what kind of characteristic did you use, especially soil characteristics?
Okay. Thank you very much for such a nice question. In my case, as I highlighted in the research design, I used the finite element method in the analysis, and also I used the Morgenstern price method in the GeoStudio. So this is the first part. And in terms of soil parameters, there were different soil parameters depending on the case study. Like you can see from this one, I fixed all the parameters like the cohesion, internal angle of friction, but these parameters were taken from the ICOD guidelines by reading the guidelines for the homogeneous ones. But for case studies, we used some real parameters from the design, but only for the Ndembele Dam, where I had to subject the embankment to different permeabilities. as you can see, from 5 to 5 times 10 power minus 5 to 10 power minus 7. And for other dams, then I use the specific parameters from the design.
Okay,
So
thank you.
Timothy.
And
Timothy, so
Hello, yes, hello.
please, Pavel.
okay,
For you?
just one, you said you used geotechnical parameters
Yes.
which determined in laboratory, or it was different parameter in literature?
These parameters are lab-based ones. In the catchment where we couldn't retrieve soil samples, then we tried to take them from the design team, and we got this one. Like the one from the Ndembela, we got it from the University of Dar es Salaam, because in Ndembela, when they designed the embankment, they asked the University of Dar es Salaam as a consultant. So the University of Dar es Salaam gave us data from this dam. And in some cases studied that we couldn't retrieve this kind of data, then the lab-based process had to be done.
Okay, thank you. And my second question,
Mr. Chairman, Zbigniew Lechowicz is speaking. Sorry that I am so late, but right now I'm present.
Yes. Yes, we already fixed.
Okay. Okay.
Yes, yes. Good morning. Good morning. Thank you very much. So now second questions, Pavel.
Yes.
Yes, second questions. How did you take into account groundwater for catchment, for calculation flow in catchment? Because this factor may impact more than runoff.
Yes. It's a very good question. In this kind of modeling, the base flow, we make it 0. Why? Because we would like to only capture the effect of the surface runoff and not the base flow. Because when the land surface cover goes to maybe curve number 98, it means you have more of an impervious surface cover and less of the base flow. So in this case, we have an option in the model to select base flow as 0, so that we can only capture the effect without taking into account other factors. Because as I have already mentioned, when it comes to land surface cover, we worry more about when we have almost 100% impervious surface. And in this case, we expect that the influence of base flow to be almost negligible, because most of the runoff will run on the surface than percolating to the ground.
Okay, thank you.
Thank you very much for such a nice question.
So, Timothy, also Pavel, during time of giving questions, Dr. Pavel Kotov also said about what model of soil, and during time of your calculation you use. What is model for finite element analysis? What is your model soil ground you use?
Maybe I have not understood.
Is,
when you say
Coulon, Treska, Prager, what is the soil ground model you use? Lineal or not lineal? What is model? You know?
For when we use the finite element method, in this case, the other model, like the linear, the plasticity, these kind of things, are somehow ignored, because I use the finite element method plus Moeller-Coulomb, especially for the slope stability. In this case, we don't have a mechanism to include the other type of models.
So only one type of models, right?
Yes. And it was important for me to keep everything constant, so that I only capture the effect of the parameters of interest I wanted to investigate.
Okay, thanks.
Thank you.
Next questions.
I have one question.
You have some? Please.
Yes, one question. Thank you for your presentation. My question is, on the basis of the findings of your research, what is the message you would like to convey to the field of embankment dams?
Okay, thank you very much for such a nice question.
Mhm.
As I already mentioned before, that it's only very unfortunate that these parameters are ignored when it comes to designing embankment dams. But I think the future is somehow compromised. If we don't take these parameters into account, what is happening right now in the Msimbazi catchment in Dar es Salaam is likely to happen in many other catchments in the world, and also many dams out there are at high risk. So my message to the researchers, especially in the field of embankment dams, I think it's a high time now to start investigating these parameters.
Thank you for your reply.
Thank you.
So please,
Thank you for
another questions?
Thank you for presentation, Timothy. I have one question. Apart from the land use and land cover analysis, what could be other potential uses of GIS with respect to embankment dams?
Thank you very much. GIS actually has a wide range of application, but for embankment dams, I think apart from the land use and cover analysis, we can also use GIS for real-time monitoring, especially monitoring the water levels in the embankment. And also this can help us to develop an early warning system so that if there is any problem, we can act faster before we have a problem somewhere. So we can also use GIS for a real-time monitoring for early warning systems.
Thank you.
Thanks. Have you other questions? I think enough, maybe okay. So thank you very much. So now, if no questions, the word is given to scientific advisor, PhD, associate professor, acting professor of Department of Civil Engineering of Eurasian National University, Dr. Utepov Yelbek Bahitovich. Please.
Thank you, Professor Spekov. I would like to share my screen with my review for the thesis of Timothy. I will just read it shortly. Regarding the urgency of this topic, in the field of dams, stability remains a crucial requirement all over the world. Therefore, protection, retention, and permanent evaluation of the dam stability are essential. Timothy has been able to publish more than 3 papers in local journals, 3 papers in the international journals with high impact factor and percentile in Scopus. The highlighted potential effect from the combination of water level and rapid drawdown conditions provide highly useful information in the embankment dams design for highly sustainable dams. The results derived in this study showcase the significance of incorporating the factors such as land use change and climate conditions in the design of embankment dams. After carefully reviewing the thesis report, I can undoubtedly state that the author has done an outstanding job and that the thesis is ready for this. The thesis is really nicely written. The thesis of Timothy meets all the requirements for degrees, and I would like to mention that he really did a great job during his studies, during writing this thesis. We had many meetings with Professor Zbigniew, his international supervisor also, and I think based on aforementioned, Timothy deserves the PhD degree. Thank you.
Thank you, Dr. Utepov. So I think if no questions from members of dissertation council reviews, No questions for Dr. Utepov? Words? No. So if no questions, the word is given for foreign scientific advisor, Doctor of Technical Science, Professor of Department of Geotechnical Engineering at the Warsaw University of Life Science, and the Vice President of Polish Geotechnical Society, Dr. Zbigniew Lechovich.
Thank you very much, Mr. Chairman. Once more, sorry for delay, but I had the problem. Okay, but it is my review. You have you've got this review, and first of all, I would like to tell you and point it out that based on the World Declaration Dam of Safety, there are several questions coming to what we have to do the better dam for better work, and I think that team of and subject of this this PhD thesis is very suitable for what we have to do in the world concerning to the dam safety. And as you can find in this review, I pointed out that PhD student prepared several papers, and it was published, and all requirements are fulfilled. And what was also important from our side, that he made a very good job, and he spent 3 months. Sorry that due to COVID situation, he spent through this internet, but it was very useful internship, because 3 months we had a meeting every Friday, and all discussion and all information what we've got together and analyze it was very important. And from degree of validity and credibility of scientific, I can say that research work presented by PhD extent and also enlarge knowledge about the influence of selected factors on assessment of embankment dam stability. It was very important and very updated what we have to do these days looking to the dam safety. And I can say that from scientific point of view, the most important issue of and original and scientific achievements, it is that proposed model of assessing the influence of climate changes and land use. It is very important, and he added the special issue which is related to soil material characteristics, just to make the proper assessment of stability of dam stability during rapid drawdown and long-term steady state conditions. And just taking into account the our work and based on the careful and detailed analysis of the text of PhD and discussion during this, what I mentioned before, international scientific internship, and also subsequent online meetings, I can say that everything was prepared in the proper way, and theses are ready for defense, as I already said. And from my point of view, the candidate meets all requirements, and procedure can be followed as you are doing right now for civil engineering specialty. Thank you very much.
Thank you. Thank you very much for review reports, Professor Zbigniew Lechovich. It is a very informative and very deeply confirmation from you. And I want to also additional inform, so Professor Zbigniew Lechovich, one of big specialists of dam engineering and hydrotechnical engineering in the world, not only in Poland. Also, he worked very well long time in Iraq, in the Mosul and the Erbil area for international projects. So he has real had and has a real good experience regarding of interactions of embankments and dams with soil ground. So thank you very much. So have some questions from reviewer, from to supervisor, from council's members. No questions. Thank you. So now we move to scientific secretary Asil Serikovna. So Asil Serikovna must be inform us about some documents from department. Asil
Okay,
Serikovna.
thank you, Professor Rusupekov. So now I'm going to explain about the resolution of extended department meeting on the preliminary examination of the thesis of PhD student Mkilima Timoth. So the first, to approve the positive conclusion of the extended meeting of the Department of Civil Engineering of the Eurasia National University from 13 May 2022. So the second, to recommend the thesis of PhD student Mkilima Timoth entitled Aspects of Embankment Dam Stability, considering the impact of land use change and the climatic condition on the catchments, submitted for the degree of Doctor of Philosophy in the specialty of Civil Engineering for defense of the Dissertation Council of Architecture and Construction. Okay, thank you.
Thank you. So will there any questions from members of Dissertation Council, reviewers and the supervisors for this presentation from Asil, Dr. Asil? No questions. So the word is given to the official reviewer, Dr. PhD, Professor of Department of Civil Engineering, Indian Institute of Technology, Madras, Chennai, India, Adimolam Buminath Khan. Please.
Good morning to all. Thank you for Saraskar for inviting me for this PhD dissertation council meeting. Congratulations, Timoth, for your nice presentation and also good work. Also, I congratulate both Professor Utepo and Professor Lechovis for guiding this wonderful work. I have a few questions only. Some of the questions already asked by Professor Paolo and Oscar. Before that, I would like to know from Timoth, could you please tell us 2-3 important research contributions from your study?
Can you please repeat?
Could you please tell us 2 or 3 important research contributions from your study? Research contributions.
Okay. Thank you for such a nice question. As I also highlighted before, number one, we can see that I proposed like some sort of model that can be followed if we are to take into account these land use surface cover and climatic conditions during the design and analysis of embankment dam. So this is a very new model, and I would like to take it to the scientific community that they start thinking of this. And also number 2, as I already mentioned, that nowadays, normally when we design these embankment dams, we take more into account the long-term steady-state conditions. But we have to understand that the more you increase the long-term steady-state factor of safety values, you decrease the factor of safety values from the rapid drawdown. So it is significantly important to optimize. Rather than opting for higher values, you have to take both into account and then you come up with an optimum value. This is number 2. But number 3 is, I've pointed out already, that I think it's a high time now also to include this land surface cover as one of the inputs in the ICOLD, because this one currently has been completely ignored. At least the climate change has been somehow discussed in the ICOLD, but land surface cover has been completely ignored. So this is high time now also to include this part in the ICOL.
Okay. Looking your conclusions, it looks like more results actually. It may be applicable specifically for particular dams actually. Why you have not written a generic conclusion? Generally, PhD thesis, we can do, after getting result, finally we have to conclude so that your research will be applicable to for other site conditions, other dam sites actually, instead of focusing particular dam actually. You are implementing your research through some dam, but finally you have to also make conclusion more generic actually for earthen dam, instead of only focusing 2-3 dams actually. You have any comment?
Maybe I would like to say that the fact that I used maybe more case studies, it just to get a better picture, so that at the end of the day we can have the general conclusion. But in my case, the general conclusion is that in fact the land surface cover in catchment is changing. The population is increasing in each and every catchment. The scenario is similar. So when it comes to all the other catchment in the world, the land surface cover is changing, and I think we also know that the world climate is also changing. So in each and every embankment dam, before designing it, it's significantly important to take these two factors during the design phase into account before coming up into conclusion that this is the final design.
Okay, now we'll go to the modeling aspects. Of course, our first question from Professor Pavel on that only. Could you please explain how do you do finite element analysis, then also stability analysis? I think what I understand, these are two aspects actually. You would have used the software, but anyway, as a PhD thesis, you should have given more details about the finite element analysis.
Yes.
Most of the questions are related to that one only actually.
Just
the software name slope W, it is not adequate actually. Okay.
Can you repeat that?
No, just saying that you are adapted slope W software or CPH software, that is not adequate for PhD point of view. You have to tell the methodology you adapted for the, for example, CPH analysis, as well as stress strain analysis. Then finally, you are doing slope stability analysis. What I understand, their analysis consists of 3 aspects. First aspect, CPH analysis. Second aspect is stress strain analysis. Third aspect is the stability analysis actually.
Yes,
in CPH analysis, how do you do? What are the governing equations, boundary conditions you are adapted? Similarly, you have to tell us for a slope stability analysis, particularly for stress strain analysis, what type of material model used and material properties you are selected. Of course, you already mentioned about material properties, but we would like to know more about models actually. That already Professor Askar told us some of the name of the models actually.
Yes, thank you for such a question. In my case, as I've in the report, I've explained in detail this, but I would like also to highlight that in each type of the model I had to create. Number one, I had to subject the embankment to seepage analysis, and in the seepage analysis, I have to feed the model with all the required materials. And the results from the seepage analysis are then used as parent to the slope stability analysis. And in the seepage analysis, we use SIPW. And the seepage analysis generates pore pressures that are then used as a parent to the slope stability analysis with mainly sigma W and Morgenstern's price method. So in general, the SIPW actually uses a finite element to calculate everything, but when both like the seepage analysis and the slope stability have to always be taken concurrently, because the results from the slope seepage analysis are then used as the, as I've already mentioned, as the parent to the slope of stability. And in each model, as I've mentioned, I worked on maybe, I think, around maybe hundreds of models. And in each model, I have to do the same. The first step, I do the seepage analysis and provide all the boundary conditions required in the model, all the materials required. And then I use the results to the slope stability analysis. I also assign all the materials required in the slope stability analysis, and then come up with the results.
Okay, understood. But you are not done any stress strain analysis?
Stress strain analysis, because in this case, in stress strain analysis, we can take into account if we use coupled flow analysis. And in coupled flow analysis, we take into account the reservoir weight. But in my case, the interest was not to account for the reservoir weight itself, but the interest was to account only for the rapid drawdown and the water levels. And if we subject the embankment again to the reservoir weight, then we have some sort of an influence from the reservoir weight. So it was significantly important for me to get an understanding from mainly from the water level and the rapid drawdown only, without taking into account other factors.
Okay, how do you estimate the excess pore pressure build-up to drawdown?
The excess pore pressure during the drawdown is estimated, as I said, I use the finite element method. Then the excess
that's what you are not mentioning us actually. So you are saying finite method, but that's what is our question actually. Anyway, please think about at least for your supervisor advice to have more knowledge about how to write, particularly that part actually. Okay, I don't want to further ask question in that direction. Okay, how do you check the results are correct or not?
How do we check?
You got some result from slope W. How do you show that the results are correct or not?
The results from the slope stability analysis and seepage analysis. The first thing, as I said in the presentation, that at first I had to subject the research into homogeneous embankment. Okay. And from this homogeneous embankment, I had to investigate, because when you subject this embankment to maybe rapid drawdown, there is a general aspect of either maybe the flow of the factor of safety values that you have to observe. And then if you are satisfied with this one, and then this way you can proceed. But in some cases, you might find that you subjected the embankment, but if there is a problem somewhere, then even the graph itself or the output will have some sort of indication that somewhere there is a problem. But if everything is fine, then as I've shown from the graphs, you will have nicely computed graphs with some sort of rebounding, soil rebounding after the drawdown.
Okay, my question is also related to the how do you select the mesh size actually? Okay, it depends on the mesh and element selection only. Finally, the accuracy of the result actually. How do you select the mesh size?
Yes, thank you for this question. The mesh size is selected because I had in each model, I had 3 types of mesh sizes. Number one, the coarse one, and then I take it to the lowest, like maybe 0.05. And looking at when I generate the results, I will see that if this mesh size is too much, then you have congestion. Then you have to take it a little bit back, as like you increase it the coarse size until you have nicely delineated mesh in your embankment. And then after that, you can I select this one for the analysis. So it was a process.
Okay, so by iteration process only, you are finally arriving the size, doing trial and error analysis.
Yes. Yes, because there is a guide for mesh size required for a range, and then after that you have to do a trial and error until you get to a place where you have sufficient mesh size, but is also well delineated.
Okay. So you have done both stormwater modeling as well as hydrology, as well as geotechnical aspects. So which is your strong aspect of your thesis? Which part of the thesis makes significant contribution?
The strongest part is on the slope stability analysis, because the other parts were significant input to the slope stability. All I did from the land use and cover analysis from stormwater modeling is just to come up with a slope stability analysis at the end of the day.
But you are not given importance to the selection of geotechnical parameters, I think. But you are not done any laboratory tests, or you are not done any field test, or you have, of course, referred literature from that you are adapted, but you are not given importance to that aspect actually. Because finally your results all depends on the input parameters only. Okay. For example, angle of friction or cohesion, okay, unit weight. So how do you select that one?
As I said before in one of the questions, that these parameters, these parameters are not just selected. For like if you go for the Ndembela Dam, I said that this firm that designed the dam, they did their investigation at the University of Dar es Salaam. That's where we got the data, because in some cases where we were able to retrieve data from a consulting firm, I retrieved data. But in some cases where retrieving data from a consulting firm, or maybe anyway it was difficult, then we have to subject the samples into lab analysis.
Okay. Thank you for your reply. But anyway, you have to further study on particularly finite element analysis and modeling. Okay. But anyway, your work not only focus that aspect, it focuses more multidisciplinary, both hydrology as well as GAs. And from that aspect, definitely your thesis is very interesting. Of course, you have done more studies, case studies, as well as model studies actually. Congratulations once again.
Thank you very much
for your good work. Also, the supervisor for guiding the good work. Thank you.
Thank you.
Thank you, Professor Gumi. I think it's now is okay for interactions. So yes, you're right. More concentrated to numerical analysis. So he not provided some model tests and field tests, but anyway, he used more statistically observation methods and also used numerical analysis more deeply. So I think it is okay for his dissertation. But anyway, if you have no questions, I think his time is extremely going well. So I want to give word to official reviewer, Doctor of Technical Sciences, Professor of Department of Construction Productions, Tyumen Industrial University, Tyumen and Russian Federations, Dr. Pronozin Yakov Alexandrovich.
Hello, dear colleagues. Thank you very much for your presentation and your answers. And I read my written review, and I ask you to read a little bit shorter than I have written it. And criteria of my review, the little of the thesis. In his work, Timothy Mkilima investigates aspects of embankment dam stability, considering the impact of land use changes and climatic conditions in catchment areas. There is a significant number of embankment dam failures and accidents all over the world. Urbanization remains one of the most crucial environmental challenges in developing countries. The author of this science work distinguishes and considers the main problems of embankment dam stability, such as the impacts of land use and cover changes on the stormwater, climatic impacts of stormwater-related issues of dams, and stormwater estimated methods. Importance of science. Due to its results, the investigation has led to a significant amount of new knowledge created in the scientific community. As a requirement for the PhD program, the author has published 5 articles in local journals, 3 papers in foreign journals with a percentile higher than 25%, and 3 papers in conference proceeding at both local and international conferences. The principle of self-reliance. The author of the dissertation carried out a substantial amount of the research himself, including the analysis of existing cases as well as computer modeling in various programs, and collected the data that is presented in the PhD thesis. The principle of internal unity. The aim of the thesis is and its objectives are clear, and the relevance of the thesis is well justified. The following main scientific achievements have been accomplished in the dissertation. First, assessment of the potential applicability of GIS methods for dam characterization and selection, assessment of the urbanization rate based on the trend of land, cover changes in the study of catchments. It has been found that the application of GIS-based method with high spatial resolution imagery to extract geomorphical characteristics of the catchment proved useful for dam site selection. The principle of scientific novelty. The author offered a new assessment of the potential impact of loading conditions on stability of embankment dams influenced by land use, land cover changes, and extreme climatic events. The results and conclusions of the work are partially new. The validity of the main conclusions. The results of the research work are based on the author's computer's modeling in specific GIS and other programs. The main statements presented for the defense. The work identifies the problems of embankment failures due to changes in flow characteristics in the catchment and could be useful for predicting the behavior of embankment dams in processing. This option was found on the basis on the extensive investigation that was included in the PhD thesis. It is possible because existing studies have not sufficiently captured the relationship between shifting water levels and loading conditions on embankment dam stability. When it comes to keeping the operation of existing dam or dam design, the following must be considered: potential applicability of GIS methods for dams, assessment of the urbanization rate estimation for stormwater runoff, assessment of the potential effects of runoff changes on the flow characteristics and well as potential effects on the flow characteristics changes on the stability of embankment dams. Quality of writing and design. The thesis is well structured. The arguments are clear and the wording is simple and persuasive. And I have only one recommend to your work. Some formulas are given without dimensional designations. It would be right to take this into account in your future work. That's all. Thank you.
Thank you. Thank you. So please, Timothy, you can you reply for some remarks,
formulas
or you agree? Remarks
about
for
some formulas are given.
reviewer report. Yes.
Maybe can you please repeat that part, that some formulas are given without?
Замечание, говорит, повторите. Please repeat. Только замечание, да.
Some formulas in the text of thesis are given without dimensional designations. For example, page 30, I remember, without dimensional designations. Безразмерные величины.
No units.
Timothy, in your thesis, your thesis.
No units,
30
no units.
pages.
Okay.
No units, yes.
Okay, thank you. Okay, I will check I'll take into account that.
Okay. That's all.
Можно продолжать?
Yes.
So, Timothy, you agree,
yes.
да?
Yes, I said that
You
I will
agree
take
with
that into account.
remarks?
Yes.
Okay, I haven't any question.
Okay.
Скажи, почему вас не слышим?
Yeah.
Нет, слышно сейчас?
Сейчас
Слышно?
нормально. Да, сейчас хорошо.
So, if Timothy difficult find, it is better say you agree. It is okay.
Hello, yes, I said yes, I will take that into account. Okay, hello, can you hear me?
Скажи, почему он говорит хорошо?
Okay, thanks. So, if no questions for reviewer, for Professor Pronozin, so now in the case we beginning discussion. So the following discussions, all the members of Defense Committee can make some discussions, presentations shortly. So who would like to speak? Кто хочет участвовать в дискуссии, кто скажет несколько слов про диссертацию, пожалуйста, please.
Я могу сказать. I want to say, first of all, thank you all for participation during the PhD thesis defense of Mkilima Timoth. I would like to appreciate many efforts also from Professor Zbigniew. We've been working on really important things for the thesis of Timothy with him. Thank you, reviewers, Professor Bumikhan, Professor Pronozin, for nice reviews. Thank you all for having us during this meeting. And I would like to wish best of luck to Mkilima Timoth in his future career. Thank you.
So thank you but we need some discussions regarding of contents, regarding of dissertation and presentation, etc. Please, who want?
Yeah, I would like. Can I start?
Who?
Pavel Kotov.
Okay, Pavel, please.
Okay, Timothy used in this dissertation different methods like geoinformation system, geotechnical and climate modeling, calculation of dam stability. I think it's a great job to figure out in these topics. I think Timothy deserved Doctor of Philosophy degree, but I would like to see next time presentation with description of methods in detail. like equation, description of model, limitation of model, and reason of choosing this model, and so on. Because today there are a lot of questions connecting with this issue. Okay, thank you.
Thank you, thank you.
Thanks. So this is Timothy, you not reply, only members of council meeting discussions, you only listen. So thank you, Dr. Kotov, please.
I want to say,
Dr. Shachmov.
Yes, the topic is very interesting regarding to the dam, especially for the existing dam, because he write that it is he doing some research related to the different level, like 10, 8, and 6 meters, and doing some work related to the calculation. Especially in the condition of the changing the weather and the problem of the water. Also the runoff water is also a problem because we should analyze where it is decreasing, where it is maybe increasing. So, but as said another colleagues, yes, in the dissertation it will be better if you did some work related to the properties of the soil, soil conditions, and how the pore water change, and also some analytical information about the dam failures in the world, and giving some percentage of the dam failures in the world. What is the reasons, and how the run of the waters is influence or not influence to this to the stability of the dams, and give some propagation and related to the future work related to this topic. I think this topic is very interesting, and we should investigate this topic not only from the and I didn't see the information. I don't know. Is it the rivers? How much the percentage of the runoff and how much the percentage of the underground water is the source of these rivers, and how much the urbanization and how the urbanization works is influence to the runoffs. I mean, especially related to the foundation procedures, depend on the type of the foundation and so on. But the work is very interesting, and I think it's good work, good job. Thanks.
Yes, thank you, Dr. Shachmov. So some discussions. No, I think is enough, maybe, no? Only shortly, I won't say shortly about these topics. So Timothy, very active work in our department, especially for these topics. So after many publishing, he also made many presentations in international conference. So last conference was in Macedonia about 1 week ago. So we made poster presentations in Macedonia International Geotechnical and Rock Engineering Conference. So in our poster sessions, visited several VIP people, especially president of Rock Mechanics Engineering International Society, professor from Turkey, Professor Razin, and also Professor Mark Belows, new president of International Society, also visits our posters. So we have good discussions because most of them has very interested about these topics. So maybe in future we'll be also connect with, I recommended to Timothy connect with these two presidents. And I fully support of these dissertations and for working positively, because it is very interesting for our country, not only for Tanzania, also for our country and also for CIS country. I hope also from East Europe, from Poland and other countries like Russia and Uzbekistan and Tajikistan, which we have also done in India. So if no questions, I give words for holding secret voting by using our smart KZ system. I won't give words to scientific secretary. And Dr. Tulibekova.
Okay, thank you. So, dear members and reviewers, to conduct a secret voting, you need to select a PhD student, Mkilima Timoth, from the list in the Smart UNO system. And after that, please click Conducting Defense. The voting windows open, and you have to choose one of the options. So, please start. Уважаемые члены диссертационного совета.
Доктор Василий, оппоненты тоже вошли, да? Оппоненты вошли.
Да, рецензенты тоже.
Тоже. Окей, говорите.
Еще на русском повторю. Пожалуйста, зайдите в систему Smart UNO, и сейчас будет запущено голосование. Вам нужно будет также выбрать докторанта Тимоти Мклима. На верхнем углу в правой части вы найдете, значит, проведение защиты и будете видеть, значит, кто, ну, список, да, у вас такой выйдет, какие варианты есть голосования. То есть давайте вместе откроем и начнем.
Это мы открываем зеленую, да?
Да, сначала выбираете Тимоти Мклима. Вверху в правом углу нажимаете зелененькую «Проведение защиты». Пока делайте, я сейчас должна еще позвонить в технический отдел, чтобы они также проконтролировали этот процесс. Спасибо.
Грация проголосовал.
Я проголосовала.
Я тоже.
Хорошо, уважаемые члены диссертационного совета, а также рецензенты, я сейчас все проверю. Минуточку.
Доктор Селия, вот у меня написано проведение защиты, да, и написано Мкилима Тимоти. Дальше куда он должен нажимать я? Селия, слышно, да? Селия, слышно меня?
Там, по-моему, надо сказать, просто галочку ставить и...
Слышу, Скажи, говорите.
Выставить там слово, по-моему.
Да, вот я вижу докторанты проведения защиты, фамилия Мкилима Тимоти. А вот как выйти на голосование?
Нажимаете на эту зелененькую.
Да, нажимать надо на зеленую кнопочку.
Ну что?
На зеленую кнопочку надо нажать вверху.
Ну что-то не двигается, неактивное.
Сейчас я в технический отдел сейчас позвоню.
Все остальные проголосовали, да?
Да, скоро.
Все проголосовали. Мы ждем сейчас. Еще
Все,
я не проголосовала.
Все проголосовали.
Система грузится.
У вас тоже вот это не выходит активность, да?
Да, сейчас пока не выходит. Сейчас система загружается. Подождать надо. Голосование длится минут 5-7. Ждем.
Mr. Chairman, Zbigniew Lechowicz is speaking. Am I right that reviewers do not have the right to voting, yes?
Yes, yes.
Okay, okay. I wouldn't be sure.
Reviewer, no, reviewer is voting, reviewer. Supervisor, no voting. Reviewer is voting. Reviewer is voting, supervisor, no voting.
I'm saying about the supervisor, of course, of course. Okay.
Supervisor, no voting, no voting.
Okay,
No
okay,
voting.
thank you.
Sorry, little bit wait because this time is extremely going, but a little bit wait because some technical problem. Don't like this system, though. I don't like this system. Very old Soviet style, the Stalin system. Да. Fantastic, да.
Stalin system very good.
System. Russia says system is very good. Russia. Dr. Sergey, system is very good, huh?
Yes, yes, of course.
Maybe this system good if we have 20 members. 20 members. Because in the Russian system, in the Russian country, the dissertation committee, 20 members. 20, 25, sometimes 30 members. But council meeting, council dissertation committee. But we have not so big like American style. So it is difficult for a small group. It is enough, maybe some open discussions. But for all Russian Soviet Union system, we have council members around 20 minimum, 25, 30. Maybe secret voting is important. Maybe.
Maybe.
Василия, что там у нас с главным корпусом? Какие-то нету связи, да?
Здравствуйте, я извиняюсь, я разговаривала с техническим отделом, значит, у нас произошла такая техническая неполадка. У Аскара Жакпаровича, значит, не вышла регистрация. Это техническая ошибка, поэтому сейчас, профессор Жуспеков, пожалуйста, вы озвучите свой голос, запись идет. У нас 100%, получается, голосование прошло. Вам нужно будет озвучить свой голос, получается, сейчас здесь.
Нет, там,
я озвучиваю голос.
Протокол же вышел же, по-моему.
Нет, Роман Арбекович, протокол вышел, но у нас будет сейчас 8 человек, а нам надо 9, поэтому Аскар Жакпаровича сейчас публично, вот здесь идет у нас запись, он свой голос назовет, да? За что он голосует?
Да, я называю свой голос положительно, плюс за.
Все, спасибо.
Okay?
Ага, спасибо.
Ну, спасибо, что за доверие.
Аскар Жакпарович,
Тимати, I support you. А?
Наших 3 этих, получается, счетных комиссий. Угу.
Да.
И они озвучат нам.
Счетные комиссии, значит,
100%.
Значит, мы выбрали Кудрявцев, Шахмов и Уразова. Нет возражений?
Да, и, пожалуйста, у нас...
Нет, это формально.
Да. Угу.
Да, пожалуйста. Я думаю, возражений нет. Почему? Потому что... Да, пожалуйста, Василий.
Нет, говорите, я сейчас регистрирую.
Три наших представителя, 3 члена Диссертационного совета: профессор Кудрявцев, associate профессор Шахмов и associate профессор Уразова. Нет возражений? Нет, да? Все, спасибо. Значит, это формальная счетная комиссия, потому что у нас электронное голосование, но в любом случае протокол надо потом заполнить, типа электронной подписи, наверное, да, Василий Серикович?
Да, будет электронная подпись. Сейчас я еще на экран попробую вывести протокол, и вы будете видеть протокол голосования. Хорошо? Минуточку, пожалуйста. Что-то у меня все зависло. Сейчас, минутку.
Она появилась, да, Асия, потом исчезла.
Вы сейчас на экране что-то видите? У меня просто экран висит.
Нет, пока не видим, ничего нету. Нет ничего. Но мы его так кратко очень видели, очень кратко. Но я не знаю, там зафиксировали люди. Я зафиксировал, что 8 за.
Да, все верно.
Цифру
К
такую.
сожалению, с интернетом
Правильно?
немножечко проблема. Сейчас я попытаюсь еще раз, если уже не получится.
Не получится. Тот, который мы очень так кратко видели, я думаю, это уже в глазах, в памяти
Посмотрите,
осталось.
пожалуйста. Я думаю, сейчас вы должны...
Все видно, сейчас видно.
Да,
Так.
уважаемые члены
да.
диссертационного и рецензенты, у нас 9 вообще присутствующих. Как мы уже сказали, у Оскара Паровича техническая ошибка, поэтому итого вместе с его публичным голосованием получилось у нас 9 за присуждение степени. Да? Пожалуйста, наша счетная комиссия. Кто-то один выступите.
Так. Наверное, Сергей Анатольевич, выступите, да?
Согласно протоколу.
Микрофон отключен.
У вас микрофон
Скажите,
отключен.
что да. Сергей, включи. Сергей Анатольевич. Микрофон включите, Сергей Анатольевич.
Он подсоединяет наушники. Минуточку.
Отключен был микрофон.
Да, пожалуйста, да. Все, вот теперь можете просто протокол огласить.
Оглашаю
И
протокол
на этом,
голосования диссертационного совета. Защищаемый Мkilima Timoth, специальность строительства, код специальности. Тоже тема диссертации аспекты устойчивости насыпных плотин, учитывающие влияние изменений землепользования и климатических условиях на водосборных бассейнах. Дата заседания 27 июля 2022 года. Защита на английском языке. Голосовали 9 человек. Присудить ученую степень доктора философии, PhD или доктора профиля 9 человек. Против нет, воздержавшихся нет. Прошу утвердить этот протокол.
Спасибо, Сергей Анатольевич. Прошу проголосовать. Кто за? Руки просто поднять. Кто против? Кто воздержался? Все, спасибо, единогласно. The protocol of the commission is approved. So based on public defense reviews and official reviews and the results of secret voting, the dissertation council, the directions of defense examinations by specialty civil engineering in Gumilev University, National University, decides to award the degree of Doctor of Philosophy, the specialty civil engineering to Mkilima Timoth. Let's more. I congratulate you, Timothy, for these results of defense examinations. Like this, that it must be.
Congratulations.
Thank you. And let's move to discussion the draft conclusions. So every has draft, I think. Dr. Serikana, you send this draft, да?
Yes, yes.
For each members, right?
Right.
So we have, you can see the nature of thesis results. You can see this thesis results as what is better, what is better. Number theoretical statements or solutions to scientific problem or scientifically justified technical, economical, and technological solutions. I think 812 is okay. 812. Второй, да? 812. And the level of novelty. Results are new. Some of the results is not new. Much of the results are not new. So I think is maybe also 822. Okay? Второй вариант. Второй пункт. Agree? Okay. And the value of thesis results high and satisfactory and unsatisfactory. I think is maybe again second position 832 satisfactory. And relation of thesis topic the planet of research. So I think is also second one is better maybe. The topic is included in the basic research program, industry program plans of scientific organization and higher educational institutions. I think is okay. Second one. And finally, we have also the level of implementation of the results of thesis. So I think is maybe also 852, the inter-industrial level, So if you agree, so we will be sent of our main office of our Eurasian National University of doctoral students the doctoral students program of this final our qualifications of PhD thesis items. The final vote was given to PhD students Timothy. Timothy.
Hello.
You're here.
Yes.
So this final words very shortly, please. You can speak if you like.
Okay.
Some appreciation, etc., please.
Yes.
Or not appreciation.
I would like to take this opportunity to sincerely appreciate everyone here, and please allow me to appreciate the support I received from the supervisor, Dr. Yerbeck. It was significant, and as you understand, there is an issue of huge documentation and so on. It was a really significant support. Please also allow me to specifically also sincerely thank the Professor Zbigniew, and also please pass my sincere gratitude to Dr. Skutnik also, and also Professor Askal as an individual. Thank you very much for your support during these 3 years of my PhD. Dr. SL and Dr. Jambolat and everyone here, the reviewers, thank you very much. I really appreciate. Thank you once again.
Thank you, Timothy. Now, so the meeting is already considered over, finished. So thank you for all, because this time is extremely going well. So we have second defense examinations. Anyway, deep thanks for especially for reviewers, for foreigner our guests. So very important for us for interactions, because we must know also the some reviewer and some your view about our PhD thesis, also very important for us, international view. So thank you very much. So now we have about 3-minute break, 3-minute break. So after this 3-minute break, we're beginning and second our defense examination. Можно загружать, наверное, Асель, да? Серикина, вторую презентацию, да?
Да, сейчас я остановлю запись и начнем вторую запись. Всем спасибо. Здесь же остаемся. Просто я останавливаю запись.
Всем спасибо большое.
Thank you very much. Спасибо большое.
Yes.
Thank you very much.
Congratulations. Good
Thank
luck.
you very much.
Good luck.